Miss Ramirez, and in this segment, we're going to be learning about thermal energy. So before we get started, I do have an animal friend that I'm going to show you guys today. And before I show him to you guys, I'm going to give you some clues. So listen to those clues so you can guess. This animal has 4 legs. He has a long tail. He has spikes on his body, and he has a big patch of skin underneath his chin that looks like a beard. And he also is an omnivore. That means that he eats fruits and veggies, but he also likes to eat bugs. So think about, what animal do you know of that has 4 legs and a long tail? And I'm going to go ahead and pull him out. So make your guess. And if you guys said a lizard, you would be correct. This is a special type of lizard called a bearded dragon. His name is Spike. Now, remember I said he had a beard? So underneath his chin, he has a big pouch like a beard. And when he gets scared, or if he's trying to scare something away, he will inflate that beard like a big balloon. So this is Spike the bearded dragon, and he depends on thermal energy. For example, the sun. He needs the sun to help keep him nice and warm and to help regulate his body temperature. So the sun is an important source of heat for all life on Earth. So I'm going to go ahead and put our animal friend up. That was Spike. And now let's go ahead and talk about what exactly is thermal energy. So thermal energy is essentially the movement of particles within an object or a substance. And I know Mrs. Schramm briefly went over the word kinetic energy. Kinetic just means movement. So for example, all things are made out of particles, super tiny particles that we really can't see. When something has a lot of kinetic energy, those particles are moving around super fast. And it's that super fast movement of particles that creates thermal energy, that heat. So just imagine super fast particles moving around. That is what creates thermal energy. It's the movement of particles creating heat. So for example, if you guys take your hands and rub your hands super, super fast, you're going to generate, your hands are going to feel warmer, right? So that's an example of creating thermal energy. I also want to show you guys my pretty cool mood ring. The mood ring has a special substance in it, and this is going to be a big word. This is thermochromic liquid. That just means that it changes color in response to temperature. So we're going to keep track of my ring and the colors that it changes as I go through this presentation. So right now it's blue, but we're going to see what other colors it can change as we move on. And that is because, guess what? Your body has heat too. So I'm pretty sure you guys are familiar by now with thermometers. So the thermometer is measuring your body temperature, the amount of heat you have. So if I turn on our little thermometer over here, let's see what my body temperature is. Hopefully it says I have a good temperature. So I'm going to go ahead and put it on my forehead and we'll see what it reads. And it's about 98.3 degrees Fahrenheit. So we can use thermometers to help us measure our temperature. We can use a digital one just like this, and we can also use one of these. So the way a thermometer works, it has a liquid. It's normally red. When it gets really hot outside, that liquid is going to rise to the top. Now remember, the liquid is rising because when it gets hot, those particles that make up the liquid are moving super fast and they're expanding, they're getting bigger. And that is what causes that liquid to rise to the top. So when you see the red liquid all the way in these top numbers, it's probably super hot outside. I think today it's supposed to get up to 90 degrees. So that's kind of warm. When it gets cooler outside, when we lose heat energy, when it gets cooler, the liquid inside the thermometer will actually go down. And that is because the particles that make up the liquid, they're going to start to slow down. And particles that are slower are usually going to be cooler. So when you see the liquid go down, that usually means it's going to be rather cool or cold outside. Now, to show you how a thermometer works, that rising or dropping of that liquid, I have another tool to show you guys. Sometimes it doesn't work for me because sometimes my hands are super cold. So I'm a naturally cold person, so I'm going to cheat a little. I found some hot hands hand warmers. So maybe during the wintertime when it's super cold, you might take one of these and it'll warm up your hands. So inside there's a substance, and what's happening is there's a chemical reaction. Something's happening inside this little baggie and it's giving off heat energy. So I'm just gonna warm up my hands just a little bit so I can cheat. Oh, look, my ring turn is still purple, kind of like a purple blue color. And I'm gonna take this, and this is gonna represent our thermometer. So again, we have our little liquid inside. I'm gonna take my hand, I'll use this one since I warmed it up. I'm gonna put it underneath this little bulb and look at the liquid. Hopefully it's gonna rise to the top, just like our thermometer did. So when the liquid gets warmer, the particles that make up that liquid are bouncing around all over the place. They have a lot of energy. It's causing it to rise to the top. And then eventually, when that liquid gets cool, the particles inside are gonna slow down and it's gonna start to drop to the bottom. So this shows us how a thermometer works. So the next thing I wanna show you guys, we're gonna move on to one of the most important, in my opinion, one of the most important sources of thermal energy, and that is the sun. So we kind of touched on the sun with light energy. So the sun actually can give off various forms of energy. It gives off light energy because it lets us see, but it also gives us heat energy because it keeps us nice and warm. And you guys saw an example of an animal that depends on that heat energy with our bearded dragon friend. So notice he has a heat lamp right over here. This heat lamp is connected to an outlet. So it's actually changing electrical energy into heat energy that is warming up our friend, the bearded dragon. And I actually put a thermometer underneath the heat lamp. So how hot do you think it is underneath this heat lamp? Go ahead and give me a number and we'll see. I'll give you a hint. If you guys were listening earlier, I said that today's high was going to be what? So what temperature was it going to be today at the very midday? So it's actually almost 90 degrees underneath that heat lamp. So it's actually rather warm. And again, here's our thermometer. And you can see bearded dragon, our friend Spike, loves that warmth. On the other end, I have another thermometer that's not under the heat lamp. So what temperature do you think this thermometer is going to read? And it's actually rather cool in my room today. It's about 72 degrees. We typically call that room temperature. So it's much cooler on the side that doesn't have the heat versus the side that does have the heat lamp. So there's our little animal friend. And so we already talked about temperature. So temperature is just how we can measure that heat energy. And of course, we learned that we can use a thermometer to help us measure the amount of heat. And something that some kids always kind of get confused on is things like jackets and coats. We're starting to get into the fall weather. Do you think jackets and coats provide us with heat energy? Yes or no? And hopefully you guys said no. So coats and jackets are a little bit different. Coats and jackets are what we call an insulator. They do not give off thermal energy, but they do keep us warm. Our body is supplying the heat, and then the jacket that we are wearing is simply trapping our body heat and keeping it from escaping into the cooler air. So just remember that the coats and blankets that you guys use, they are not a source of thermal energy. They are something different. They are just called an insulator. And I have a couple little experiments before we go. This first one is a type of slime called unicorn barf, and that's because it's color changing. So remember my color changing ring? It reacts to temperature. Here I have some slime. I'm going to practice my safety and I'm going to use some tongs. I'm going to put my slime on top of a hot candle. So notice my slime is like a blue color right now. What color do you think it's going to turn when I get it a little bit warm? I'm adding heat to this slime and we're going to see if we can make it change colors. And hopefully you guys can see it changed colors. It's now a kind of like a light blue color. The next thing I want to show you guys is I actually put my ring on this hot hand warmer pouch and it did change colors. It is now a kind of like a yellow purple color. And then the last thing is another little toy. This is a color changing touch board. So remember, our body has heat. It's converting the food that we eat from chemical energy into heat energy. So I'm gonna take my hand, because again, I have heat, and I'm gonna slap it on the board, and you're gonna see my handprint that's left behind. And I think that's all I have for you guys today. So that's all I have for you guys for heat energy. I do have a challenge for y'all. I would like to see if you can give 3 examples of how you or your parents have used thermal energy today. So I'll give you a hint. Think about things in the kitchen.